Very good evening, one and all present to here. My name is Ruben, handling the chemistry subject 6 years. So today I am going to present about the very important topic Grignard Reagent, which is most important for every competitive exams like NEET and IIT. So the first of all, if you analyze the Grignard reagent, before you should know that the meaning of organometallic compounds. So what is that meaning, that organometallic compound? Then naming itself, you can easy to analyze that. Any compound consists of metal and carbon bond is known as the organometallic compound. So this word, it's called upon organo, it represent about the alkyl group, which means that hydrocarbon derivative, and metallic, it's nothing but highly electropositive nature of the any metal. So now if you categorize the organometallic compound, alkyl group, it's attached with the metal, and here I want to categorize the three important categories for explaining about the Grignard reagent, how it will be formed. So first of all, in the first case, this metal, I am going to take the electropositive nature of the group 1 element like sodium and potassiums. So now what will happen? In this particular case, the alkyl group attached with the group 1 element like sodium. So now what will happen? So between the two area, the percentage of ionic compound, the percentage of ionic character is increases. So therefore what will happen? Therefore the solubility, it can be this particular compound, organometallic compound, soluble in the polar solvent. Similarly, in third categories, here I am take the alkyl group, and this particular alkyl group, it's attached with the metal like a tin or lead or thallium, so and so on. So now what will happen? The percentage of ionic character somewhat decreases. So you know very well, if it is a percent in any ionic compound, the percentage of ionic character increases. Obviously, the covalent character also increases. If it is observed that covalent character is more on the inorganic compound, so that particular salt, it can easy to soluble in the non-polar solvent. It's a non-polar solvent. Okay. Now the third category is, here I am introducing the magnesium. You know very well, the magnesium, it identically to lose the 2 electron to attain the stable electronic configuration for magnesium 2+. So now the alkyl group of hydrocarbon derivative, that can be attached with the magnesium. So now what will happen? It producing the covalent character, but even though it's a polar. So how it is possible? The reason is the two bond connectivity between the alkyl group as well as halogen group. So metal and halogen, this particular interaction showing the ionic character, and meanwhile the alkyl group and magnesium, this particular alkyl group and magnesium group, it's showing the it's not purely covalent. So actually it exit in the nucleophile in the form of alkyl group. So keep in mind, so this is nothing but Grignard reagent. So from that Grignard reagent, it's a highly nucleophile for the alkyl group. So how it is possible? First of all, you take that any alkyl group, now you take the magnesium. So as a result, what will happen? So this bond breaking between the alkyl carbon and the halogen. So that particular two compartment is going to be added to the magnesium. So as a result, what will happen? We will get back the RMgx or mgx. How it is possible? You know very well, in the magnesium, it lose the 2 electron, it will become the magnesium 2 plus. So as a result, when you take that alkyl halide, so under the homolytic cleavage, it will be producing the single electron present in the one alkyl group, another single electron present in the halide group. So these two electrons are it's connected to the magnesium. So as a result, I got the RMgx. RMgx, I am going to be get that. So from this Grignard reagent, I can expect that it is a R group, it is a nucleophile. R group, it is a nucleophile. So what is the purpose of using the Grignard reagent? In order to make the functional group conversion. For example, I take the carbonyl compound. So what is meaning that carbonyl compound? The carbonyl compound means the C double bond attached with the oxygen. So in this particular area, this is sp2 hybridization and it is a trigonal planar structure. So when you add with the Grignard reagent, now what will happen? When you adding the this Grignard reagents, now what will happen? This particular nucleophile is going to be attack highly electrophile center of the R group. So as a result, what will happen? This negative charge, pi bond is shifted towards the highly electronegativity of the oxygen atom. So as a result, I got the unstable intermediate of the alkyl group. So now here the sp2 hybridization, it's converted into sp3 hybridization. So therefore, if it is a hybridization is changed means according to the VS EPR theory, geometrical structure also is changed. Here tetrahedral intermediate, unstable of intermediate I can able to get. So as after that, followed by I just do with the protonation. Now what will happen? This particular O minus abstract this proton, then it will become the alcohol. Excuse me. So now I got the corresponding R group. Okay. Now what will happen? The carbonyl functional group sp2 of the reactant, it's converted into the corresponding alcohol. So as a result, I got the carbonyl group of aldehyde or ketone or carboxylic acid, whatever may be, I can able to get the corresponding alcohol. So let him do with the example of the cyclopropanone. For example, I have the cyclopropanone. This particular cyclopropanone, it's converted into 1-methyl cyclohexanol. So how it is possible? So this functional group, okay, here I have the ketone functional group. This particular ketone functional group, it's converted into the tertiary alcohol. So we need, first of all, we need to identify the functional group change. So here ketone functional group. What is a ketone functional group? The C double bond O consists of 2 R group. So here in this particular case, here I have the CH2 homologous series. Here acting is here 2 alkyl group. Now I am introducing the corresponding R group. So what type of R group I need to add it here with the help of Grignard reagent. A Grignard reagent, you know very well, it is the RMgx. In the particular RMgx, the R group consists of methyl. So now I have the CH3, magnesium and any type of halide. So now, you know, usually in this particular R group act as a nucleophile, is a electrophilic of the carbonyl group is going to be attacked. So I can expect the unstable intermediate of the alkoxide group. So now O minus and CH3 I will be get back that. So after I do with the protonation, now what will happen? The O minus abstract the proton, I can expect the alcohol. Oxygen, C double bond O, and this is for CH3 and this is for CH3. So now this is a way of getting the tertiary alcohol, secondary alcohol and primary alcohol. So I want to preparing the primary alcohol. So what type of corresponding functional group it's required? It's nothing but formaldehyde. It's a formaldehyde. Formaldehyde treated with the one equivalent of the RMGX. I can get back the primary alcohol. So if I take the aldehyde functional group, I treated with the again on equivalent of the RMGX, I get back the secondary alcohol. Similarly, I want to get the tertiary alcohol, means I take the reagents and just do the treated with the ketone functional group. So therefore, I got the classification of the variety of alcohol by using the variety of different covalent functional group. So what is that? Now I just clarify that what is meant by the Grignard reagent. So Grignard reagent is one of the organometallic compound. In that particular organometallic compound, the metal consists of magnesium. So that will be producing the Grignard reagent. In that particular Grignard reagent, R group acts as here. It is a nucleophile. That nucleophile is going to be addition reaction with the carbonyl functional group. So if you take the variety of the carbonyl functional group, formaldehyde treated with the RMGX, we get the primary alcohol. So and aldehyde functional group you treated with the RMGX, we get the secondary alcohol. Then you treated with the ketone functional group, you get the corresponding tertiary alcohol, you will get that. So thanks for your observation. Have a nice day. Thank you.